Hello everyone. So we're going to do indefinite integrals now with inverse trig. Okay, but before we get started with that, I'm just going to have you guys in the warm-up try to rewrite these expressions as perfect squares. Okay, so we know that what number squared will give you 64. So you can write that as like 8 squared, right? Because 8 times 8 gives you 64. Now, what squared would give you 9x squared? That would be 3x, right? Squared. And then thinking about this one, this would be what times what would give you 16x to the fourth. That would be 4x squared, right? And then we know this one is 5x, but to what power squared would I get the 6? Well, if you think about it, with exponent rules, you multiply the exponents, right, to get the power. Just like here, if I multiplied in part C, 2 times 2, that would give me the 4. So what times 2 would give me 6? So this has got to be cubed, right? So just kind of recalling that x to the m, oh, that looks really ugly. X to the m to the n is x to the m times n, right? And so that's how we can figure that out. Okay, so we're going to need that later in the lesson when I now talk about how to do this with u sub. But just so we can just check that you guys get the gist of what's happening with this class practice right now, we're going to basically just recall the antiderivatives now that give you these inverse trig functions, right? So when we did derivatives back, before Christmas break, when we were just learning derivative rules and stuff, we did do derivatives of inverse trig. So the derivative of tan inverse was 1 over 1 plus x squared. And then the derivative of sine inverse was 1 over the square root of 1 minus x squared. Okay. And then just to recall that tan inverse of x is the same thing as arctan of x. And then same idea with sine inverse is the same thing as arcsine. Okay, so sometimes they'll use those interchangeably. I do believe the AP exam tells you that in the very beginning, though, that they are equivalent. But just in case you don't see that on your page for whatever reason, just recalling those facts. Okay, so looking at part A, what I can do now is I can rewrite this as the integral of 3 times 1 over 1 plus x squared dx, just so you can see that this is just going to be 3 tan inverse of x plus c. Okay. All right, so I'm going to let you practice B and C, and then we're going to go on to the back.